Today we're going to look at how to verify trig identities. What's nice about this lesson is that we're giving you the answer and you need to simplify one side of the equation knowing what your final answer should be. So it's kind of an automatic check on your work whether or not you did it correctly. So on our first slide here, and again you've got this on your vocab sheet, it's kind of some options that you can choose from in order to verify the identity. So let me show you what our first example looks like and then we'll go back over our different options. So on one side it's much more complex than the other side. So that's what our first step is telling us, is to choose the side that's more complex and simplify. It's much more challenging to try and make something simple complicated or complex. Second one, use those identities that we looked at. Pythagorean is a really common identity that we'll use quite a bit, so hopefully you're getting those memorized. If you've got a fraction, you could split it up, or if you're adding or subtracting fractions, you'll want to find a common denominator and combine them. And typically, if you convert to one trig function, or if you can convert to sine and cosine, and then rewrite it as tangent or cotangent, that's helpful as well. All right, so starting with our first expression and using our Pythagorean identity for tangent squared equals secant squared minus 1, I'm going to rewrite that numerator. I'm going to leave the denominator alone for now. And what we're going to do is divide our fractions using our property of division. So when we divide, we multiply by the reciprocal. So I'm going to start with tangent squared times the reciprocal of secant. So instead of putting it as 1 over secant, I know that secant is the reciprocal of cosine, so I am just going to multiply it by cosine squared. And then I'm going to rewrite tangent. Tangent is sine over cosine. So we've got sine squared over cosine squared. Notice how I'm not dropping the x. I don't say it because it gets a little complicated, but I am still writing it. So make sure you do the same. And then of course you can see our cosines cancel, leaving us with sine squared of x equals sine squared of x. Again, that automatic check on your work, so it's really nice to know right away that you simplified correctly. Next we have two fractions, so I'm going to get a common denominator, which would be both of these denominators multiplied. So I'm going to multiply this by 1 minus sine x over 1 minus sine x. Running out of room, so I'm not going to multiply the whole thing. And this one will be multiplied by 1 plus sine of x over 1 plus sine x. So in the numerator on that first one, we've got 1 plus sine of x, plus the numerator of the second one will be 1 minus sine x, all over 1 minus sine x times 1 plus sine of x. And somehow we'll get this mess to equal 2 times secant squared of x. All right, so in our numerator, it simplifies nicely. The signs cancel, so we're left with 2. And in the denominator, we're going to have to multiply these binomials together. What's really nice about these is that because they are conjugates, that sign is opposite, it simplifies really nicely when we multiply this out. So we get 1 times 1 is 1, and we will have positive sine x canceling with negative sine x, so we don't really need to write that. And then minus sine squared x. And again, we'll get this equal 2 times the secant squared x. So in the denominator, what we have is a Pythagorean identity. Remember, I'm going to go off to the side over here. Sine squared plus cosine squared equals 1. So if we want to rewrite this so it's 1 minus sine squared, that would equal, subtracting sine squared from both sides, we would have cosine squared. So I'm going to rewrite my denominator as cosine squared using that Pythagorean identity. And hopefully you can see what our last step is going to be now. Cosine is the reciprocal of secant, so we get 2 times secant squared of x, which is exactly what we should. And our last example before your U try, what this might look like is FOILing. But the first thing that we would do is tangent squared times cosine squared, and then we would have a big mess. So what I'm seeing instead are two Pythagorean identities. Tangent squared, we'll go off to the side here again. So our Pythagorean identities, tangent squared equals secant squared minus 1. So when I rewrite this to be tangent squared plus 1, that will equal secant squared. So that's the first substitution. The second substitution is that Pythagorean identity with sine squared plus cosine squared equals 1. So if we rewrite this one, solving or subtracting 1 from both sides, we would also have to subtract sine from both sides. So I'm subtracting 1 from both sides and subtracting sine from both sides. So we get cosine squared minus 1 equals negative sine squared. And somehow we'll get this to equal negative tangent squared of x. Next, I'm going to use our reciprocal identity for secant squared. Secant squared is 1 over cosine squared times negative sine squared of x. And hopefully you guys remember that tangent is sine over cosine. So we have negative tangent squared of x. Lost my negative on that one. I noticed as I'm writing this down again, we have negative tangent squared of x. So here's your try question. Remember, think about those Pythagorean identities, think about the reciprocal identities, but stick with one side first and see what you can come up with.